section, we are going to talk about the difference between a power function and a root function. We'll deal a little bit with domains. And then in the next section, starting tomorrow, we'll start solving like equations and inequalities involving these things. So when I talk about a power function, so it's something of the form f of x equals x to a power. I'm just going to put b is a constant. Okay, so there's no variable in the exponent. X to the third, x to the fourth, x to the fifth. Those are power functions. A root function is something like 1 over a number for the exponent, which is the same thing as saying you have the nth root of x. So a root function might be written with a radical in it, or it might be written with a fraction as the exponent. They are equivalent. If we're dealing with domains, in a power function, what's your domain? What can x be? Anything. Okay, if we are dealing with a root function though, we have two cases. If you have an even index, the index is that number outside the radical, so my n. Tell me what kind of root. So if,
has to be greater than 0.
Mm-hmm.
Greater than or equal to.
Right. So the thing under the radical greater than or equal to 0. If you have an odd index, so a cube root, a fifth root, a seventh root, what can x be? Anything, because you can have a negative under an odd root. So domains, the case we really have to worry about is if you have an even index on your radical. Then the radicand, the thing under the radical, has to be greater than or equal to 0. Alright, let's start just by seeing if we can simplify some radicals and evaluate them, and then we'll start throwing variables in. So what is the cube root of 27?
3.
Because 3 to the third power equals 27. Alright, B. It's an even root. Does it matter if there's a negative on the outside? No. All that will do is carry over into my answer. What is the fourth root of 10,000?
10.
Do you guys know how to do those on the calculator if it was one you weren't sure of? If you go into math, there's a cube root option, or there's one that has like an x. So you would type in like the 4 first and go into math, go down to that option, and do your root. Side note, I am missing 2 calculators. So please check. If I don't get them back today, I won't let people use my calculators anymore until they come back. So check to see if you may have one of my calculators. C. The cube root of negative 216. Negative 6, you cheater. Using your calculator.
So making sure that I remembered how to use it.
Yes, it's a good idea. Everybody make sure you know how to put that in your calculator. D. The fourth root of negative 81. So the fourth root of 81 is 3. What happens if you do the fourth root of negative 81? It gives you an imaginary, because can we have a negative there? No. So for our purposes, let's just say, okay, so I guess two answers. We could deal with i's, or we could say it does not exist, there isn't a solution. If you try to put this in your calculator, if you say the fourth root of negative 81, what does it tell you? It'll tell you domain error, because this isn't included in the domain. So our answer would kind of depend on if we were dealing with imaginary numbers or not. We could do it either way. So either with the I or no solution if we are only dealing with real numbers. All right, what if we have fractions? Just like the top and the bottom, we could do those separately. So the cube root of 125 is 5 divided by, what is the cube root of 512? Well, okay, so type it in on a calculator. What is the cube root of 512?
8.
So it's 5/8. All right, F. The negative on the outside stays. Then what is the fifth root of negative 243?
3.
Be a negative 3. And then if you have two negatives, it becomes positive 3. Are we okay with simplifying radicals? What if I gave you these? So the difference is these are written with rational exponents. We have a fraction in the exponent instead of writing it as a radical. But they are equivalent. When I say 16 to the 3/4 power, what does that mean?
The fourth root of 16 cubed.
Mm-hmm. And you could do the cube before or after, but if we're doing it by hand, it'd probably be easier after. What is the fourth root of 16? And then 2 to the 3rd power? What is the cube root of negative 64? Negative 4. And then what is negative 4 to the 4th? And it becomes a positive because that negative is inside the parenthesis. 4 negatives will become positive. All right, C. So we have some options. If you have a power to a power, what do you do with those? Multiply. What is 3/4 times 2? Then how do I write that with a radical?
Square root of 25.
Square root of 25 is 5. And 5 to the 3rd power is last one. So this means the cube root of negative 8 to the 5th power. Cube root of negative 8 would be negative 2, and negative 2 to the 5th. Negative 32. Any questions about those? Okay. So there's a reason I was having you practice all these by hand without just putting all of them in the calculator, because we also have variables that we need to be able to use. So this one is really just practicing exponent rules and what we need to do here. So if I want you to use rational exponents to rewrite it, what do I mean by rational exponents?
Something, example, 5 square root 2.
That's with the radical. So the rational would be like writing it as a 1/2 power or something like that. So writing it without the radical, but with an exponent. So when I have the 5th root of x, how do I rewrite that?
X to the 5th.
Okay. This is the square root of x cubed. So that would be x to the 3/2. Alright, now if you are multiplying the x's written each time, what do we do with the exponents? Add them. So 1/5 plus 3/2. So x to the 17/10. And we could certainly rewrite that as a radical if we wanted, but I just asked you to do the rational exponents. I'm going to do C next. So I'm going to go out of order here. So the whole thing is under a cube root. So that means this whole thing is to the 1/3 power. Inside it, I have an x squared times, when I see the 7th root of x, that means x to the 1/7. So then, inside here, we would add our exponents. So 2 plus 1/7 would be 15/7. And then what do we do with our exponents? Multiply. So we get x to the 5/7 for our final answer. I want you guys to try B and D. B, how would I rewrite that first one?
X to the 4/3.
And the second one?
5/4.
So then, because the x is written each time, what do we do with the exponents? Add them. So you get x to the
31/12.
last one. So this is a 6th root, so that's a 1/6 power. Underneath it, we have an x times the cube root of x squared would be x to the 2/3. You have to add these exponents. This is like a 1, so 1 plus 2/3 to the 1/6. So then 5/3 times 1/6. So far, so good? So next, let's talk about domains. If we want to find the domain of these, we know it depends on if we have an even or an odd index on our radical. So if I look at the first one, this is a square root, so an index of 2. 2 is even. So if you're finding the domain, what do you have to do? The radicand, the thing under the radical, greater than or equal to 0. That means 4x is greater than or equal to -12. So x is greater than or equal to -3. How do we write that?
Bracket.
Yeah, that's my question.
To infinity. Parentheses, yeah.
Alright. What about this one? What would we do? It's,
Okay, no.
we're just doing the domain.
It's negative.
Because it's an odd index. It's negative infinity to positive. I'm gonna throw one more up here. So, what would we do?
Would you break it up into the factor?
We will have to factor it, yes. So we know it's a square root. So that means whatever's under the radical is greater than or equal to 0. But this isn't as easy as just getting x by itself, because when you have a square and an inequality, we have to do things a little bit differently. We haven't done it in a while, but we have solved quadratic inequalities. This factors into 6 plus x, 6 minus x. So we did it a couple different ways. Sometimes we've talked about graphing the entire quadratic, or we were just doing rational inequalities where we're doing sign lines. So we could do it like that. What are the two things that make it equal 0?
Positive 96.
So if you do test points, okay, we are plugging these numbers into our inequality. So if I put in negative 7, I get a negative times a positive, which is a negative. If I put in a 0, we get a positive times a positive, which is positive. Put in a 7, we get a positive times a negative, which is negative. Which answers did we want? Okay, do I have to worry about, can both of those get a bracket? Yes, it's not like the rational ones, there's no denominator, so they both can get brackets. So our domain is everything between negative 6 and positive 6.
That's right, this is the first time I've seen a double bracket one.
I
I've
know.
always seen
We have always done the rational ones. When we did these with quadratics, we were graphing our quadratics at the time, so we usually just looked at the graph, which you could certainly do. If it's a negative x squared, what does that tell you about the graph? It's opening down. So, it hit the x-axis at both negative 6 and positive 6. And it's opening down, so you can see it's greater than 0 in between them. So we've done it a couple different ways. This is how we initially learned it, but since we've been doing sign lines, I did it that way. Any questions there? Do we need extra practice with any of those? Last type of question. All right, we had, back when we were doing graphing in chapter 2, we had parent functions. And square root, cube root, those were two of our parent functions. And so we talked a lot about transformations. If I wanted to do transformations with this, it would probably be helpful to clean it up a little bit. If I look under here, 4x and 12, what do you notice about both of those? Yes, 4. So if we factor out the 4, okay, what that means is the square root of 4 times the square root of x plus 3. What is the square root of 4? So this function is 2 radical x plus 3. So now can we find our transformations? What will the 2 do? If you add 2, it moves it up. If you
Shift this like.
stretch it.
That's what I was
Outside changes y, so it's a vertical. So it's like taking all your y values times 2. What does the plus 3 do? So we would, if we wanted to graph it, we would take our square root function, left 3, good, and stretch it by 2. I didn't ask for the graph, but probably a good opportunity to refresh. What did the square root graph look like? Yeah, square root of 0 is 0, square root of 1 was 1, square root of 4 was 2. Okay, so if I take a stretch of 2, it's like saying, here's my y value is 0. 0 times 2 is still 0. And then go left 3. This one has a y value of 1. 1 times 2 is 2. Left 3. Here we have a y value of 2. Times 2 is 4. Left 3. So do you guys remember graphing those? So really here we're just practicing being able to work with the radical and rewrite it so that transformations would be an option. What's the domain of that? Infinity, what's your range?
0.
Why don't you guys try one? So figure out what the transformation would be here. So you could take out negative or positive 8. It would probably be easier to pull out the negative and have a positive x value. So this means we have the cube root of negative 8 times the cube root of x minus 1. What is the cube root of negative 8? Okay, what does a negative do? It's like making all of your y's, changing the sign of all of your y's to reflect over the x-axis. What's the 2 do? And the minus 1. I didn't ask for the graph, but we could certainly do it if we wanted to. What does the cube root graph look like?
The chair.
Sideways share. Cube root of 0, 0. Cube root of 1
Oh,
was
yeah.
1. Cube root of negative 1 was negative 1. And you could do 8, 2, negative 8, negative 2, so like this. Okay, so if I take 0, if you flip it, that doesn't go anywhere. Multiply the y times 2, it doesn't go anywhere. And then write 1. Here we have a y value of 1. If you flip it, it goes to negative 1. If you stretch it by 2, negative 1 times 2 is negative 2. And then write 1. Here, if we flip this, it comes up here. Y value times 2. Write 1. So we get the same shape, but it's taller. It's been flipped around. Okay, that is really the end of this section. So there is a Math Excel assignment open. You've got a lot